In this screencast, we're going to talk about our second type of heat transfer, convection. Again, you'll need your pencil, and you'll also need your journal slip, screencast, convection. All right, so convection is a little bit different from conduction. Convection is how heat passes through fluids, and a fluid is anything that has loosely moving molecules that can move easily from one place to another. Basically, fluids are liquids and gases. Take a moment to write this down on your journal slip. So one important property of fluids is that they rise when heated. That's because the molecules spread out and move apart when they get hot. The hot fluid becomes less dense and rises up, as you see here. The cooler fluid then sinks to the bottom. And this up and down motion creates what we call convection currents. And these convection currents are circular movements that help to spread the heat evenly. Now we're going to go through a few examples. Make sure that you describe these examples on your journal slip. Last night, I decided I wanted some soup for dinner. So when I put it on the stove, at first the soup was cold in the pan, and the soup at the bottom here was closest to the hot stove. So the soup at the bottom ended up heating up first. As it heated, the molecules spread apart and became less dense, and so that heated soup rose to the top, as you see here. But as that soup rose to the top, the cooler soup sank down to the bottom. And when it was on the bottom, it was again closest to the heat. So now that soup got hot, rose to the top, and that colder soup sank to the bottom. And if you were to look closely, you would see the soup moving up and down in the pot. And that up and down movement is a convection current. And that convection current helped spread the heat around until all the soup was heated up. You might have also heard of convection ovens. They work very similarly. The hot air molecules rise up, and then the colder ones sink to the bottom. And this up and down movement creates a convection current. And so that heat is spread evenly throughout the oven, and you actually get a pretty even heating of your food. Convection currents can also explain why the air is hotter at the top of the room, as you see here, and cooler at the bottom. And finally, convection currents can also explain why water is warm at the top of the ocean but gets colder as you swim deeper. I have a pretty cool video clip that lets you see convection currents on a smaller scale here. So if I hit play,
get ready for one of the most hypnotic things.
I'm just gonna move it
Container.
and take a look.
And there's a hot mug right underneath the red food coloring. As it's heated, the water rises. But I want you to look closely and notice something else. The blue on the sides is being drawn in. You can see it better when I speed it up. Here's the thing I want you to remember. When water moves from one place, it doesn't leave a void behind. Water from somewhere else has to move in to take its place. That's why you can see the blue food coloring coming in from the sides. You can see it better from above. Watch that blue food coloring get drawn in.
So here you see the warm water rising and the colder water represented by blue sinking, creating a convection current that we can see in the ocean.
The top, and then it gets pushed toward the edges by more hot water rising from underneath it. As it goes out to the edges, it starts to get cool, and cool water sinks just as hot water rises. And if you watch...
Okay, one last thing. How is convection happening in our phenomenon? Take a moment to really think about that. Basically, convection currents move the heat evenly throughout the air inside the roofs of the school. So once the metal pipes conduct the heat to the air, it spreads throughout the air through these convection currents that are happening in each of these individual rooms. In our next screencast, we'll learn about the last type of heat transfer, radiation.